assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
In this example, we're trying to determine what the magnetic field inside of a generator must be, given that we have all these other parameters of the generator here. So we have the area of a single coil, the number of total coils, the frequency with which we spin our loops at, and the maximum induced EMF. So remember, a generator is really just going to be some conductive loop or wire with many coils potentially that's rotating in some constant magnetic field or near constant field. And because the flux is changing in the loop as it rotates, we're going to get some induced EMF and therefore some induced current. So the expression for the EMF in one of these rotating loops here, like this in a constant field, is just going to be number of loops times the area of a single loop times the strength of the field times the rotational frequency times the sine of omega t. And this will give you the EMF at any given point in time, t. But if you want the maximum, we just need to remember that the sine of omega t will be maximized when it is equal to 1. So when the sine is 1, we'll have the maximum EMF, and that's just given by NAB omega. We can take this a step further. Since this is in terms of omega, and we were given frequency f, we can recall that omega is related to the frequency by 2 pi f, and substitute that in as well to have E naught equals NAB times 2 pi f. So now we're at a point where everything in our equation here is in terms of stuff we know and b. So we can solve it for b, and we will be done. So let's divide both sides of this equation by 2 pi f times Na. We can see that a bunch of stuff's going to cancel out on the right side. Nope, not that one. And we'll just have that B is equal to the maximum EMF divided by 2 pi f Na. Okay, so now all we have to do is just plug in all of our values. We'll make sure they're in the right units. Hertz, volts, turns, and meters squared. They're all standard, looks good. So we can plug those in. And if we do that, we'll get that the strength of the magnetic field is equal to 0.11 Tesla. So there you go, we just figured out the strength of the magnetic field inside of our generator, given all this other information about the configuration of the generator.